Hello, everyone. Hope you guys are having a fantastic day today. So what we're going to actually be doing today is we're going to be taking some notes on friction. Okay, so we're going to analyze friction coefficients and look at the equations that occur with friction. Okay, so if you have to pause the video at any point, go ahead and do so. But I'm going to move on into the PowerPoint. If I can find it. Oh, I had the wrong one pulled up. Okay. There we go. All right, so I'm going to present my screen here. And we're going to be talking about friction. Oh, that's my polarity one. There we go. All right, so I am going to go to, let's see, right? No, we did that. Conclusion, friction, here we go. Okay, so friction. Friction is a force that tries to prevent two other surfaces from sliding relative to one another. Okay? All right. Where you have static friction, okay? Static friction is the force that prevents the motion of a stationary object. Okay? Where kinetic is the force that acts opposite of a motion in a moving object. Okay? There we go. That's what I want to do. All right? So which do you believe will be stronger? Which do you believe is stronger? It's actually static, all right? It's going to require more energy to increase, to move it than to not move it, okay? So then, if both static and kinetic friction, the more mass an object has, the harder it is to move. So the friction is dependent on the normal force, okay? So the normal force is very dependent. So our equation looks like, friction, well, where I'm going to say force, that is friction kinetic, is equal to the coefficient in the kinetic plus the normal force. All right, and the other equation is friction, force of friction in the static is equal to the coefficient static. That should be times. Sorry. Times force normal. Okay. So there's our two equations. Okay. And that's just reinforcing. Okay. All right. So on this side, what it looks like is these are what two different materials and their static friction. So you can see steel on steel is pretty rough. But if you go on below, you might see ice on ice, and you might see Teflon on Teflon. Those are very smooth surfaces. Okay. So let's try one of these examples out. All right. So here's one of the examples. All right. And like I said, if you have to pause at any point in the video, please feel free to do so. Okay. So number 20 says, feeling quite dashing if you slide a 0.5 kilogram salt shaker. So I'm going to draw a salt shaker. There's my salt. Okay. And it's 0.05 kilograms. Okay. I'm going to zoom in just a hair, maybe a little bit more. Okay. It says to the right, you give it initial speed. So its initial speed is 1.15. If the shaker comes to rest, which is 0, with if the shaker comes to rest with a constant acceleration in 0.84 meters. Okay. So I know x is 0.84 meters. What is the acceleration? Okay. Well, I have to look at my three values and determine what equation will help me solve the acceleration. So velocity final squared is equal to the initial velocity squared plus 2ax. Okay. When you plug in your numbers, you should get an acceleration That is, I got negative 0.8 meters per second squared. Okay. All right. So in this question, what is the force of friction? Okay. What is the force of friction? So the force of friction is actually going to be the sum of all my forces in the x is equal to mass times acceleration. Okay, so my force of friction, so I've given my mass was 0.05. The acceleration I just solved for. So if you plug those two numbers together, the force of friction is actually equal to negative 0.04 newtons. Okay? That's how you would solve example 20. Oh, I'm not even done yet. I went too far. What is the coefficient of friction? Okay? So the coefficient, I got to look at one of my top equations. So since it's sliding, so what I'm going to use kinetic. Okay. So the force of friction I just solved was negative 0.04 is equal to the coefficient, which I don't know, times the normal force. Okay, well, the normal force in this problem is there's only one force acting on it up, which is going to be the same as the force acting on it down. Well, the force acting on it down is gravity. So force is equal to mass times the acceleration due to gravity. The 0.05 times 9.8. So this is actually going to equal, oh, I don't have this out. I'll find my calculator. Here we go. Okay, so I have 0.05 times 9.8. I got the normal force, or force normal, to be 0.49. Okay, and you just got to divide that number over. So negative 0.04 divided by 0.49. I got negative 0.08 is my friction coefficient. Now there is no unit for friction the coefficient of friction. Okay. Okay. So let's try number 21. You apply a horizontal force of 2 newtons to a book. Okay, so I'm going to draw my picture. So here's my book. All right, the force applied is 2 newtons. Okay, so that's force applied. Okay, I have my force normal, and the same, it's going to be the same thing for, or that's my force normal, force gravity, but they're going to be the same. Okay, so let's see, the mass of the book, so mass is equal to 0.674 kilograms. All right, the value for the coefficients of friction between the book and the table are MS and MK. Does the book move? So I got to see if my friction, so I got to see if static. So what I have is force of friction in the static is equal to coefficient times force normal. Well, I can solve for force normal, okay? The force normal is going to be the force of gravity, which is equal to mass times the acceleration due to gravity. So mass, 0.674 times gravity, 9.8. So force normal is 6.6 times, what's the coefficient due to at static? Mu static is 0.27. All right, so if you plug that in, got 1.78. So the force of friction is 1.78 going backwards. So will it move? Well, absolutely. My force applied was 2. That's greater than the 1.7. So yes, it will move. Next, I have to solve for what is the acceleration. Okay, so acceleration. So I got to look at all of my forces in the x is equal to mass times acceleration. Okay, so in the x, I have an applied force of 2. I have a force of friction. And then I have, let's see, is equal to my mass, 0.674 times A. And when you solve for acceleration, I got about 0.57 meters per second squared. Okay, so you're going to see examples like this, okay? So what I want you to do is I want you to try 22 on your own, okay? Please pause the video, okay? And I will show you how I did it. Okay, so hopefully you paused the video. Here is how I did it, okay? So here's your answer for 22. Okay, I'm going to zoom in a little bit. And hopefully it's starting to make sense a little bit. That's friction. Okay, so hopefully you got 22 to be correct. Okay, so I'm going to move on. All right, I'm going to skip 23 and I'm going to skip most of those problems. I'm going to do one more, which is number 27. Okay, I'm going to do number 27. All right, here's my new paper. All right. Let's see, 27, here we go. Okay, so you drag a crate with a rope that has a mass of 10 kilograms. Okay, so here's this. Okay, I pull it at an angle, okay, a 40-degree angle with 45 newtons. Okay, if the coefficient of kinetic friction, okay, so kinetic is 0.21. What is the normal force? Okay, so what I'm going to do is I'm going to solve for my x and y real quick. Okay. So if I look at this, I'm going to use the sine of 40 is equal to the opposite over the hypotenuse. And the cosine of 40 is equal to the adjacent over the hypotenuse. Oh, sorry, I'm going to zoom out so you can see it. There we go. Okay, so if I look at these two values, my y is going to be 28.93 and my x is going to be 34.47. Okay? So the first question said, what is the normal force? So what I've got to do is, since gravity is not the only force acting on it, that's not the same as the normal force. So I got to look at the sum of forces in the y direction equals the mass acceleration in the y direction. So the normal force is going up, right? That's my going up. However, also in the y direction, I have gravity going down. So I'm going to minus the force of gravity. My other y, I'm pulling up, is 28.93 is equal to the mass. Mass is 10. And the acceleration, is the box moving up or down? No, it's not. So the acceleration in the y direction is actually going to be 0. Okay, so the force of gravity, Fn minus the force of gravity is mass times acceleration plus 28.93 is equal to 0. When you solve for the normal force, you will get, I got about 71. Okay. What is the magnitude of friction? Okay. Well, friction, so I know force of friction is equal to mu times force normal. Well, I just solved force normal was 71 times mu was given in the problem 0.21. Well, the force of friction it's going to be 14.92 newtons. Okay, and the third question is the acceleration of the crate. So to find the acceleration, I have to consider all of my forces in the x direction this time equals mass times acceleration. Well, I only have two forces in my x direction. I have the applied and I have the friction. So the applied force was 34.47. 34.47 minus friction. Friction's going against me. 14.92 is equal to the mass times A. And when you solve for A, you're going to get 1.95 meters per second squared. Okay. So I hope that kind of makes sense. Okay, that is all we're going to be talking about friction. That's it. So hopefully that kind of made sense about friction, solving the friction coefficient. If you guys have any questions, feel free to reach out. I will answer those questions. If not, I hope you guys have a fantastic day. Tomorrow, we're actually going to be learning about tension. And that's it. That's the end of the chapter. Okay. So we're most likely going to have probably a quiz or a test on Tuesday. Monday's probably going to be a review. So anyway, I hope you guys have a fantastic day. Keep up the good work, and we will see you tomorrow.